This video is going to cover how to carry out an APS measurement on the silver sample that comes with all APS systems. First, we start with purging the APS module with 99.998% pure nitrogen gas at an initial flow rate of 5 litres per minute. The system has been optimally configured with the Kelvin probe tip over the area of the sample to be investigated at gradient 300. The light from the UV fibre is illuminating the sample under the Kelvin probe tip. At this point, we can now shut the door, critically with the toggle clamp engaged. The sample targeting LED can be used to check our alignment with the enclosure LED turned off. While we've been setting the system up for measurement, the O2 has been continuing to deplete in the APS module. We monitor the O2 depletion using the KP software in the Setup tab using the oxygen source. When this value reaches below 100 millivolts, reduce the N2 flow rate to the module to 1 litre per minute and put on the UV safety spectacles. The system is now ready for the source to be turned on using the bulb driver module. We now have to set the dark value. We do this in the photoemission source. This is done by adjusting the detector offset. This value must be close to but above 0. Now we move the UV monochromator to 220 nanometers in order to check that we have at least a 500 millivolt signal response when the sample is illuminated. This is done by starting a measurement, then opening the shutter. As we can see, this is a suitable response. Before we move to the photoemission tab, we increase the averaging for the measurement to 3. In the photoemission tab, we choose the start and end wavelengths for the APS measurement, which in this case will be 180 and 340 nanometers. Once this is done, click Go to Start. Then we can click Start to begin the measurement. Once the measurement finishes, you can save the data. Then the measurement can be processed. The black plot is read from the left-hand axis and is the raw, uncorrected photoemission data. The x-axis is the energy in electron volts. The baseline of the data is shown in orange and represents the noise floor of the photoemission. The red plot is read from the right-hand axis and is the intensity-corrected square root data. Square root data is used to analyse metal samples, as in this case. However, if the sample were a semiconductor, we would use the cube root. We can see from the plot that there is a linear section outlined by the two dotted straight lines coloured brown and pink. This straight line intercepts the baseline of the data, giving the work function value of the silver sample. In this case, the work function of the silver was calculated to be 4.602 eV. If we were measuring a semiconductor sample, we would have been measuring the valence band of the sample.